All right. Awesome. So gkurve, simpler vector graphics.
Sorry, I forgot to tell you. Please speak inside the microphone.
Straight into the mic. Yeah, got it. Cool. So a little bit about me. Started a small business. This is not the right slide. All right. So did an open source project. I've got a few friends. I like game dev. Not a huge fan of travel, but I made it here. I do a bit of coding. I like cats. I work a lot. So that's a bit about me. A bit about Mock. This is a project I've been working on for the last year. We're hoping to have a 0.2 release early next year. And yeah, the idea here is something to let you in Zig make games, visualizations, and things like that, and also desktop and mobile apps. I'd like for this to be competitive in spirit with Godot, Unity, and Unreal, but I want it to be more composable, a little bit more data-driven, and very tooling-oriented. So that's what I've been working on.
Please.
Thank you. So vector graphics, that's what I'm here to talk about. You're probably not an expert on vector graphics. I'm certainly not an expert on vector graphics, but I think it's interesting that a lot of the tooling for vector graphics assumes that you are kind of an expert. And what I mean by this is, there's quite a bit of tooling complexity. I think anybody who's ever used the pen tool in Photoshop or Illustrator or Inkscape or anything like that, could I actually just get a quick show of hands, like who's used a vector graphics tool so far? Okay, and how many of you would be like excited to use that again? Okay, I want to talk to you and you after. Yeah, so I think I don't have a lot of data points on this, but it's easy to find anecdotal evidence that I think these tools are pretty complex, and I think they're quite frustrating for people. So I kind of had this thought, which is like, what if we could create a tool that's so complex that just figuring out how to use it is actually a game in itself? If we could kind of gamify how you interact with vector graphics. And the good news is I don't have to do that because somebody already has. So if you don't know what the Bezier game is, this is kind of a game to let you learn how to use like the Photoshop pen tool and these sorts of Bezier curve manipulation functions. So basically the way that it works is you get an outline, you get a timer, and your goal is to try and recreate that outline with the pen tool. This is really cool. I think like in general, this is an interesting way to kind of like teach people complex problems, is to try and turn these into games and stuff. But fundamentally, this doesn't change the fact that like this is a complex tool to use. If you can make a game out of it, that says something. And I think in general, it's just complex, and so I want to kind of look at like why is it that these are so complex? And I think a lot of it comes down to the amount of control that you're given. So if you don't know about Bezier curves, you can have as many control points on them as you want. So you can start out with a quadratic Bezier that has a single control point. You can bring that to a cubic Bezier, which has 2 control points, and that's kind of the de facto standard. You can add more and more and more, and you can continue onward as complex as you'd like to make it. And if you manipulate a quadratic curve with one control point, the behavior there is like pretty intuitive. You click and drag it, and it moves the way that you expect it to. But if you kind of introduce these cubic Bezier paths, I think things start to get a little bit more wonky because you have so much control. Yeah, and you get all sorts of weird binning behavior, and Photop is one editor that I use quite a bit, and it always has this weird behavior where you click on a path and it just snaps to the bottom, and I don't know why. I don't know if I'm using it wrong. I don't know if there's a bug, but So the first claim that I'm going to make here is I don't think that humans intuitively understand cubic Beziers with the 2 control points on them. So what about GPUs? GPUs have a lot of smart people trying to solve this problem. They're way smarter than me, but all of these solutions kind of involve like taking these complex Bezier paths that you get and trying to turn those into triangles that you can hand over to the GPU. There are some things at the bottom here that are kind of examples of like the complex ways that these could intersect with a triangle. And you have to account for these. You have to account for these with winding rules and a whole bunch of other edge cases. But ultimately, at the end of the day, your GPU understands triangles. You have to give your GPU triangles. You're not ever going to be able to give it a Bezier path or anything like that and say, hey, draw this on the screen. That just doesn't exist. So the second claim I'm going to make is I don't think that GPUs intuitively understand cubic Beziers either. So with developers, there's this great quote by Neil Ford, which is like, I've learned recently, some very enterprise Java developer. So it makes sense, I think, that he'd come up with a quote like this. But developers are drawn to complexity like moths to a flame.
Wait, why are we not seeing these?
Oh.
Ah. Wait, what?
Well, that's interesting. Well, there we go. Yeah. So anyway, this is the quote. I think it's a great quote in general. There has been an immense amount of work on trying to get GPUs to render vector graphics. You have stuff back in 2005 from kind of infamous like graphics researchers who have done this sort of stuff. All the way up to stuff that's been done in Servo. There's a really popular game dev library called Slug. You get a lot of these things, and this is a great problem to spend a career solving. There's a whole bunch of really fun math here. You can look at computational geometry, which is like this whole field in its own. You've got the idea that maybe GPUs can become these just general purpose compute devices. You just send them Bezier curves, and then you just kind of rasterize them like that. You can work with really fancy shaders. And then Bezier curves, I think in general, are just kind of a beautiful problem to work on. They're mathematically kind of interesting. So I think that developers love working on this problem, which is kind of interesting. This kind of creates I don't know if a juxtaposition is the right word, but there's something interesting here where I think humans and GPUs don't really understand what these are, but developers love working with them. So what I'm interested in is game developers, right? I'm working on a game engine. I'm interested in game developers. What do game developers tend to do here? I think they unfortunately tend to use textures, whether this be using a bitmap, or more common these days is SDFs. So these are signed distance fields. These are something that Valve introduced. If you look at the kind of blurry texture of glyphs there at the bottom, basically the idea is that you have an image and it kind of encodes in each pixel the distance to this Bezier curve. And so when you're rendering this, you can say, okay, am I pretty close to the edge? And if I am, then I'll fill that in with a solid color, and you'll get a kind of solid shape on the left there. This is simple. It works great for fonts. If you want to have like sharp edges, you kind of have to introduce more memory. So you need more channels, and you end up with something like MSDF. This can also only represent like a single shape. So you're not going to get like multiple shapes in this. So if you want multiple shapes, you might have to like stack textures or something like that. But the most important thing I want to say here is that these are all fully baked. You have a texture that has been kind of pre-computed to do this, and you're not going to be able to dynamically change the way that the letter A works unless you're going to start doing some texture painting and try to figure out how to compute that on the fly or something. So I think my fourth claim is that game devs in general just have better problems to solve. I think that, spending a career researching how to render vector graphics is not something that most game developers are too interested in. So I kind of want to look at why are we actually using these cubic Bezier paths. There is a very good reason for this, and it's because they're pretty much curvier. They're more mathematically accurate. You can actually represent a circle with them. So on the left there, you've got like the letter R that's been produced with a quadratic Bezier, so it only has one control point. You can see it's kind of, it looks a little wonky. It's not exactly as curvy as it should be. This is kind of the de facto standard to use Beziers with 2 control points. The other aspect here is, that would just be talking about like an individual Bezier curve. But most of these vector graphics applications, you're going to be working with paths. So these are basically, you end up with multiple of these kind of stringed together. You have a big long string of them, and you have to come up with a rule to be able to fill these in. So the rule that has kind of been settled on is the even-odd rule. So you basically take any point within one of these and you kind of go to the right, and the number of times that you cross over that path, you just count that. And if it's odd, then you fill in that section, and if it's even, then you don't. My only point here is just that this is a choice. This is a system that we've kind of set up and constructed in software to render vector graphics. And so this kind of brings me to my real point, which is I'm solving a little bit of a different problem. I think a lot of people in this space kind of look towards like, okay, they're starting from a point of, I have SVGs, I have vector graphics, I have existing tooling. I have no interest in touching that or looking at that. The CPU is pretty slow at rendering these. The GPU doesn't really understand them. Like, what kind of tricks and stuff can I employ to get the GPU to render my 2D graphics that I already have? And my question is kind of starting from a different position of like, what is it that the GPU actually understands about 2D graphics, kind of intimately, and then how can I make that so that that's legible to artists? And so this brings me to gkurve. So the naming behind gkurve is kind of a funny play on words. One of my ancestors painted like this thing in Germany. So I guess quite a few years later, we're still dreaming of shapes in our family. And our last name is just good at art. So I thought it was kind of cute to name it, good art curves. So the idea here is, GPUs understand triangles. That's the primitive that they're working with in general. And it's really easy to fill in a triangle. And the thought is, okay, if we could draw a quadratic Bezier with one control point, like that's quite nice because that aligns perfectly with the number of points that are on a triangle. So if you do this, you can treat the vertices of your triangle, those 3 points that make up the triangle, as the control points of your Bezier curve. And if I overlay that animation from earlier, like you'll see, you can imagine how this would look, right? Like if you have a triangle and you're dragging the top vertex of the triangle around or whatever. Now, the problem with this is what I mentioned before, which is like these are not curvy enough to represent the kinds of shapes that you want to represent. If you want to have circles, then ideally you come up with something better than this. And so I took kind of the dumb approach here, which is like, let's draw a semicircle in the triangle. If a quadratic Bezier isn't curvy enough, then let's draw something that is actually curvy enough, and that's just a half of a circle. So we kind of end up with this table of primitives that we have to work with. And these are, basically the top row and the bottom row are, at least the 2 on the right are the same. They're just inverted, so we're just choosing which side we fill in with color. And the way that this works is really, really simple. So in GPUs, you have the ability to assign just arbitrary values to vertices. So these are called vertex attributes. And regardless of where the triangle is set up or it's positioned or how it looks, you can basically say, okay, at this point on the triangle, I'm going to give it the value of 1, and then at the top point, I'm going to give it 0.5, and then at the right point, I'm going to give it 0. We could do this as many times as we want with as many values as we want. And so in this case, we just do it twice. And what you end up with is these fields that kind of cross the triangle like this. And so when our shader program runs, it's going to run for each pixel on that triangle as it gets rendered. And you'll have access to this value as it gets interpolated by the GPU. And this is a really fast operation. This is how really basic texturing works in 3D. So GPUs are very, very good at this. And so if we take that value in one of these shaders and we just say, okay, well, on the far right, the value is 0. And so that's going to be our green color, and it's black. And so we kind of do that for each pixel, and we end up with these kind of gradients that look like this. So the really cool thing about this is with a simple x times x minus y equation here, if you have those two fields set up, if you have those two values available to you, then you end up with a quadratic Bezier. So this is kind of a very, very, very simple way to end up with a quadratic curve inside of a triangle on a GPU. This is not a new idea by any means. This is the first paper in that list of papers that I showed you all. I said that these people are much smarter than I am, and I do believe that. The thing is, the way that I interpret their paper is they kind of start out by saying like, hey, look at this, you've got triangles on GPUs, and these conveniently align with these Bezier curves that need 3 control points, and that's brilliant. These are super useful. And then they go on to try and tackle the much more involved, much more complex problem of these cubic Bezier paths that have all these weird intersection things and stuff. And so I'm trying to get like a different perspective on this, because I think it's interesting that when we look at 3D tooling for artists, if you ask any game dev or any artist or something like that, in general, I think they're probably going to tell you like triangles are the thing that make up 3D graphics, right? But in 2D, this is completely the opposite. We say, okay, well, it's either going to be the pixels or it's going to be this mathematical representation of shapes. And I find that just very strange, because you can't hand that mathematical representation of shapes over to the GPU and have it do that. You can only give it triangles. So I think that triangles are probably the GPU primitive, regardless of whether or not we're in 2D or 3D. And the other thing I'll note there is you can't get pixels onto the screen in any modern graphics API, Metal, DirectX, Vulkan, doesn't matter what it is. You cannot get pixels onto the screen in general unless you first put a triangle there and tell it how to map those pixels onto that triangle. So I want to be clear that the thought process here is that you would be interacting with and seeing these individual triangles in an editor, whether this be a Blender plugin or some sort of custom editor. The thought process here is that you would be clicking and dragging and moving these individual triangles around to create these sorts of shapes. And so you can see there's an example of kind of constructing the Blender logo out of some of these. One interesting thing about this is that it also completely removes the sort of fill rules that you get with paths. So you're no longer asking, is this a portion of the triangle that I should fill in or not, based on some complex path rules of, can I raycast outside and then measure all these things? Instead, you're just saying, okay, I know exactly, I'm only operating on a single triangle. I'm not operating on other ones or anything like that. And it's very clear what to fill in there and what not to. We can do some interesting stuff with this, because in the shader we have access to the distance to the Bezier curve, so we can get things like borders working, There's some trickiness there with getting borders to match up if you try and place multiple of these side by side and that sort of thing. But we can also use this to compute things like gradients. So since we have the distance to the Bezier, we can basically just say, okay, well, I'm going to kind of render that as a gradient.
Can you?
Oh,
Yeah.
there we go. Yeah, so that's the gradients. And the other thing that we can do is we can do some texturing. So since these are just triangles, we can apply the same concept of like UV mapping that you would see in like Blender or any other 3D modeling program to the same exact surface. And so this would let you use it for sprites and that sort of thing. So some quick notes about this. This means that the resolution on all of these is infinite. If you zoom in on anything here, the resolution would be crystal clear perfect. It's also subpixel perfect because you get access to that distance at kind of a floating point precision, right? And so you can handle anti-aliasing with these, and it's quite nice from that regard. Theoretically, it's possible to convert some of this from like convert SVGs to this, but I don't have any plans to support that personally. I'm going to go for kind of a custom editor approach. This can represent all of the same shapes. I may need to expand that set of primitives that I showed you on that table before, but I don't think so. But I still need to play around with it a little bit to be sure. The one thing I'll note there is that if you have a cubic Bezier path, a shape made up out of that, you can always approximate that with quadratic Beziers. It's not mathematically precise, but it's close enough for any practical purposes. One thing I heard was kind of a concern about like overdraw, right? Like you're rendering this for each pixel on this triangle, and maybe that's quite a lot of work to do per pixel or whatever. The thing I'll note here is that even if you have a classical like texture atlas with your fonts on it and stuff, there's a good portion of that area that is transparent, and so you have a similar amount of overdraw, I think, in practice there. But this does highlight another important reason to keep the fragment shader really simple, because if you're evaluating the cubic Beziers with 2 control points in them, your fragment shader becomes much more complex, and obviously the runtime performance and stuff slows because of that. The last thing is that there's quite a lot of triangles here. Is that bad for performance? GPUs are really good at rendering a lot of triangles. The important stuff these days is draw calls, pipeline state changes, those sorts of things. And with this, you can obviously batch the same types of primitives together so that those are kind of drawn together, and you could come up with some fancier approaches to that. So if we compare SDF, like an SDF font, an MSDF font, versus like a gkurve font for just like a single glyph or something, you would end up needing a 16 by 16, maybe a 32 by 32 pixel texture to represent a single glyph. I couldn't find in their docs whether or not this is 24 bytes per pixel or 32, so if anybody knows, I'd be curious to hear it. But in any case, this means like in the best case scenario, you're going to end up at like 768 bytes per glyph. With this, you can pass in per vertex, like you're going to average about 87 for an individual glyph, and you pass in the position. That can be a half precision float since you're in screen space, and just an index about which point on the triangle are you, and so that can be quite a bit less. So we have like a test bed for this right now, and a really naive implementation of this without any of the memory optimizations, doing some other kind of rather dumb stuff. The text rendering here is not completely perfect. As you can see, like the G at the bottom is cut off. That's because my tessellator is a little wonky. But we can end up with 39,000 glyphs on the screen, which ends up being 3.5 million vertices at around 1.1 milliseconds per frame. So that's 862 or something like that. There we go. Yeah, so this is all napkin math, and that's why we've got the napkin made out of text there. But yeah, not too bad. And all in all, if this is like put together as a mega shader, and this is not the best way to do it either, given that we have separate primitives and we could render those separately, and that'd be quite a bit more efficient. This is a 75-line shader, so it's quite readable. There's not a whole lot going on here, and this includes code for handling, like the borders and not just the quadratic Beziers, but also like the semicircle rendering and that sort of stuff. So one other thing that I want to point out here is that these are, again, just triangles, and so you can manipulate these at runtime and handle these however you'd like. So you could apply the same sort of skeletal animation stuff that you would get for 3D models straight to this, and get those same sort of like animation benefits and that sort of thing. And as you change your model and manipulate it and stuff, that would all adjust. It would still remain like perfect rendering. And so in Mach, we have, like I said, a kind of a test bed for this that handles all the primitives, that does border rendering, texturing, almost has correct font glyph rendering. Like I said, there's some issues with the tessellation, but I just wanted to give a special shout out to Ziargio, who kind of helped out with the kind of like initial approach for this. I kind of, I gave him like a much less polished, presentation like this, and he was like, there's some problems here, and but he was great about just really coming in and helping out and trying to put together and piece together some of this. So the way that I envision this kind of sitting in with Mach overall is I think that we'll end up with some sort of editor for these sorts of shapes, and whether that's a custom editor or a Blender plugin, maybe both, I don't know yet. We'll have font processing, which essentially loads up a free type font and then converts that to these, handles any tessellation that's involved, and basically just spits that out to a file format that will be quite minimal to just represent these sorts of shapes, and that's it. And then you can take that and go to, handle text rendering. You could use this for 2D game visuals, for 2D character animation, all that sort of stuff. You could use this for rendering sprites, like I mentioned earlier, and also GUI rendering, which is the thing that we're obviously focusing on the most right now, is just trying to get GUI and text so that we can actually build some tools. So closing this out, I think that I'm running a Mac, so that's not a problem. I think that cubic Bezier paths don't lead to software that I can love. If humans can't understand how to work with 2D vector graphics and the GPUs can't understand how to do it, then that's not software that I love. I think it's worth exploring breaking constraints and stuff like this, especially just existing standards. Like there's certainly value in standards, but I think that computers have come a long way since then. A lot of things have changed, and I think that 2D vector graphics is a great example of that, because we've moved on from CPU rasterization. And so I think it's worth breaking constraints and thinking about different trade-offs that you might gain from doing that. Just feeling free to take into ownership of your tooling and that sort of thing. I think that better tooling in general is a case of when, not if. So I would encourage anybody, to recognize that I think there are a lot of tools out there that are maybe not so good, And that's an opportunity to improve them, and don't miss that opportunity. Maybe we discover issues with this. I had like a month to put together this talk. If you're not sold on it, like, that's fair. This is pretty much the journey that we're taking with mock. But I'd love to hear any like criticism and feedback about it. I'm very open to that. So yeah, let's make some vector graphics that you can love.
Thank you very much. That was awesome. Do we have any questions? We have about, let's see, we have about 5 minutes for questions. Okay, let's go.
One thing I noticed with the semicircle, so it almost looks like you're actually doing something like a cubic Bezier there, but like halfway through the triangle. So like you have a cubic Bezier there, but it's like instead of like control point it being at the top of the triangle, you're actually drawing like a rectangle halfway through the triangle and then using those as the control points.
Right. Yeah. That's pretty close. Yeah. I mean, essentially what we're doing is I had mentioned the fields that we have. Let's see if I can find the slide here. I cannot. Anyway, we have these fields. So we have these fields, and what these let us do is with a combination of offsetting these, we can essentially find a point that is at the bottom center of the triangle, and we can effectively generate a field that is a radius increasing outward from there. Once you have that, then it's pretty simple to just say, okay, if the distance to the center, which is at the bottom middle of the triangle, is greater than whatever, then discard those fragments. So it's yeah.
More questions? Yeah, let's go.
Great talk. I actually had 2 questions that came to mind. One was, are you going to have any support for stroking instead of filling? And then the second one was, I had no idea that anybody was trying to render vector graphics using the GPU. Is this a common thing that's been done already? This is the first time I've seen it, so.
Yeah. So to answer your first question, I'm definitely interested in getting all sorts of effects like borders and strokes and that sort of thing. I think it's definitely achievable. I almost have that working. I mentioned there were some problems with if you connect 2 of these curves together at the edges and you bend those curves outward, then you've created a gap there that you need to fill with a solid triangle. And when you do that, that solid triangle, the tip of it doesn't have a border on it, and so you need to account for that case. But I think that I don't see any problem in handling that. And yeah, so I'm definitely planning to support that. As far as people doing this on GPUs, the slide I had earlier about this one here, yeah, there's been an immense amount of research and stuff into this problem. It's a really interesting domain, and it's quite tricky depending on how you approach it. And I think there's certainly something to be said for some of the more modern approaches, which are essentially just saying, I'll treat the GPU as a general purpose compute unit, and I'll just pass everything over. I'll get a texture out, and then I'll render the texture on the screen. I think that's fairly reasonable, and it would also be quite simple. So, yeah.
You mentioned a Blender plugin, and you talked about 3D a little bit. Does that mean that you are coming up with a way to create 3D game objects using vector graphics?
It's an interesting question. I've certainly thought of this. I'm not 100% sure how it would work yet, but I think it would be possible. The challenge would be that I'm bad at math. I'll leave it at that.
Compelling idea.
Hi. So, assuming you want to do mathematically perfect simplification of what right now Bezier are, which is absolutely not a given, it might be just
Right.
an extra. What other kind of primitives were you considering?
Yeah, it's a good question. I think that the other thoughts around other primitives would be if there might be some like quite obscure edge cases where maybe you need a shape that's a curve that's somewhere between a cubic Bezier and a semicircle. That would be quite a small change, so I'm not sure how useful that would be. The other thought would be if you need a straight line that can be bent in different ways. Since you have a triangle here, obviously, you can render a fixed width border, but if you were to take one of those and smush that down, you may run into a limitation of the surface area of the triangle. So you might do something to offset that negatively and have that appear like that. But yeah, I'm not 100% sure yet. So.
Okay, couple more questions and then we go to lunch.
Not really a question, but do you know Farbrausch, the Demoscene group? It might just be interesting to look more into it. They did a demo, like I just was Googling it, in 2008 called Massalchin.
Okay.
And that was all GPU rasterization of SVG. They actually modeled SVG and they did it all on the GPU.
Right, yeah.
It might be interesting to look how they did it.
Yeah, I definitely like to check it out. The problem I've usually seen with those is that they end up with quite complex fragment shaders, and I think they'd be quite slow. Yeah.
Yeah, so two questions. The first one is, really big self-interest. Is there probably a possibility to collaborate on converting between TinyBG and gkurve? Okay, that's cool.
Yeah, I think so.
So I think it would be cool to convert TinyBG to gkurve, because then you can also benefit from the SVG to TinyBG generator and basically support the SVG files indirectly.
Yeah, the SVG to gkurve conversion is tricky because you are working with the paths that I had mentioned, where you need to kind of handle the even odd rule for determining what's considered inside or not. You can do things like sort of what I'm doing with the fonts, which is essentially take those paths and then tessellate them and handle the outlines and that sort of thing. But it doesn't necessarily produce the most optimal representation of it. And so I think that it might be something nice to have, and I'd like to explore it, but I think the primary interface should be just manipulating those triangles directly.
So the other question is, do you want to tackle other domains with the same approach for game dev or other programming tasks we did?
What do you mean by other domains?
For example, whatever sound or generating pixel graphics or whatever.
Yeah. Anything specific to that? Probably not. I think that this general approach of I always go back to Minecraft for stuff, because I think that it's really worth exploring how far you can get with some simpler primitives. I think that is something that's very valuable and quite underrated these days. So I think that I would like to explore that a bit more in those domains. but I'm sure it would look very different from anything like that. So.
Okay, so before we give a final round of applause to Stephen, I just want to point out that Stephen is also running the Z monthly, bi-monthly mailing list, so, newsletter, so please make sure you check that out. And also, I think, Stephen, you were pointing out that it is a lot of effort to come up with a regular newsletter, so would you be open to maybe somebody who's interested also in doing that to collaborate with you?
Absolutely, yes.
So
Yeah.
also looking for contributors. Okay.
Thank you.
Thank you very much. Please,